friends, welcome to my channel. In today's topic, I will explain you about theory of relativity. So friends, without wasting any time, let's begin. In 1905, Albert Einstein determined that the law of physics are the same for all non-accelerating observers and that the speed of light in a vacuum was independent of the motion of all observers. This was the theory of special relativity. It introduced a new framework for all of physics and proposed new concept of space and time. Einstein then spent 10 years trying to include acceleration in the theory and published his theory of general relativity in 1915. In it, he determined that a massive object causes a distortion in space-time, which is felt as a gravity, the tug of gravity. Two objects exert a force of attraction on one another known as gravity. Sir Isaac Newton quantified the gravity between two objects when he formulated his three laws of motion. The force taking between two bodies depends on how massive each one is and how far apart they two lie. Even as the center of the earth is pulling you toward it, keeping you firmly locked on the ground, your center of mass is pulling back at the earth. But the more massive body barely feels the tug from you, while with you much smaller mass you find yourself firmly rooted thanks to the same force. Yet Newton's law assumed that the gravity is an innate force of an object that can act over a distance. Albert Einstein, in his theory of special relativity, determined that the laws of physics are the same for all non-accelerated objects, and he showed that the speed of light within a vacuum is the same no matter the speed at which an observer travels. As a result, he found that the space and time were interwoven into a single continuum known as space-time. Even that occurs at the same time for one observer could occur at different time for another. As he worked out the equation for his general relativity, Einstein realized that massive objects cause a distortion in space-time. Imagine setting a large body in the center of a trampoline. The body would press down into the fabric, causing it to dimple. A marble rolled around the edge would spiral inward toward the body pull in much the same way that the gravity of a planet pulls at the rocks in space. Experimental evidence. So, friends, now we talk about the experimental evidence of this theory. Although instrument can neither see nor measure space-time, several of the phenomena predicted by its mapping have been confirmed. Gravitational lensing. Light around a massive object such as black hole is bent, causing it to act as a lens for the things that lie behind it. Astronomers routinely use this method to study stars and galaxies behind massive objects. Einstein's cross, a quasar in the Pegasus constellation, is an excellent example of gravitational lensing. The quasar is about 8 billion light years from Earth and sits behind a galaxy that is 400 million light years away. Four images of a quasar appear around the galaxy because the intense gravity of the galaxy bends the light coming from the quasar. Gravitational lensing can allow scientists to see some pretty cool things, but recently, what they spotted around the lens has remained fairly static. However, since the light traveling around the lens takes a different path, each traveling over a different amount of time, scientists were able to observe a supernova occurs four different times as it was magnified by a massive galaxy. In another interesting observation, NASA's Kepler telescope spotted a dead star known as white dwarf, orbiting a red dwarf in a binary system. Although the white dwarf is more massive, it has a far similar radius than its companion. The technique is equivalent to spotting a flew on a light bulb 3000 miles away, roughly the distance from Los Angeles to New York City. Avi Spooker of the California Institute of Technology said in a statement, change in the orbit of Mercury. The orbit of Mercury is shifting very gradually over time due to the curvature of space-time around the massive sun. In few billion years, it could even collide with Earth. Frame dragging of space-time around rotating body, the spin of a heavy object such as Earth should twist and distort the space-time around it. In 2004, NASA launched the Gravity Probe GPB. The presently cabled satellite caused the axis of gyroscope inside to drift very slightly over time, a result that coincided with Einstein's theory. Imagine the Earth as it if it was bare were immersed in honey. Gravity probe principle. Investigator Francis Ivety of Stanford University said in a statement, as the planet rotates, the honey around it would swell. And it's the same with space and time. GPP confirmed two of the most profound predictions of Einstein's universe, having far-reaching implications around across astrophysics research. Gravitational redshift. The electromagnetic radiation of an object is stretched out slightly inside a gravitational field. Think of the sound waves that emits from a siren of an emergency vehicle. As the vehicle moves towards an observer, sound waves are compressed but as it moves away, they are stretched out or redshifted, known as the Doppler effect. The same phenomena occur with the wave of light at all frequency in 1959. Two physicians, Robert Pound and Gillian Rybka, shot gamma rays of radioactive iron up the side of a tower at Harvard University and found them to be minutely less than their natural frequency due to distortion caused by gravity. Gravitational wave. Violent events such as the collision of two black holes are thought to be able to create ripples in space-time known as gravitational waves. In 2016, the Laser Informator Gravitational Wave Observatory LIGO announced that it was found evidence of these telltale indicators. In 2014, scientists announced that they had detected gravitational waves left over from the Big Bang using the background imaging of cosmic extragalactic polarizing BEPS telescope in Antarctica. It thought that such waves are embedded in the cosmic microwave background. However, further research revealed that their data was contaminated by dust in the line of sight. Searching for the unique record of very early universe is as difficult as it is exciting. Jan Tober, the European Space Agency, project scientist for the Planck Space Mission to search for the cosmic waves, said in a statement. LIGO spotted the first confirmed gravitational wave on September 14, 2015. The pair of instruments based on of Lucin and Washington has recently been upgraded and were in process of being calibrated before they went online. The first detection was so large that, according to LEGO spokesperson Gabriel Gonzalez, it took the team several months to analyze to convince themselves that it was a real signal and not a glitch. We were very lucky on detection that it was so obvious, she said during at the 228 American Astronomical Society meeting in June 2016. A second signal was spotted on December 26 of the same year, and third candidate was mentioned along with it. While the first two signals are almost definitely astrophysical, Gonzalez said there was less than one part in a million of them being something else. The third candidate has only an 85% probability of being a gravitational wave. Together, the two firm detection provide evidence for pair of black holes spiraling inward and colliding. As time passes, Gonzalez anticipates that more gravitational waves will be detected by LIGO and other upcoming instruments, such as one planned by India. We can test general relativity, and general relativity has passed the test, Gonzalez said. Hello, friends, welcome to Thought Zoom. Today's thought is: failure will never overtake me if my determination to succeed is strong enough. People who are crazy enough to think they can change the world are the ones who do. Third one, if you are working on something exciting that you really care about, you don't have to be pushed. The vision pulls you. Fourth one, it's not whether you get knocked down, it's whether you get up. Fifth, last and fifth, you learn more from failure than from success. Don't let it stop you. Failure builds character. So friends, sorry for the disturbance in the video. My voice is not enough clear, but don't forget to subscribe my channel and do not forget to share this video to your friends, and do like, share and subscribe my channel. Thank you and have a nice day.